the addition to all the sides. Okay, now that we've done with our quadrilaterals, let's move on to circles. Circles you'll read from page 477 on to page 480, and we'll do problems 1, 5, 10, 12, and 15. All right, so let's look at our problems with circles. Circles, again, is going to have more formulas, so just make sure you're referencing your formula page and don't get overwhelmed because you'll have it with the test. So let's look at number 1. And it asks you to find the circumference of a circle A if its radius is 3 millimeters. So on your formula sheet, you will have circumference, which is 2 times pi times radius. Now, don't let this pi confuse you either. It is a value, but unless you're told to use it and they give it to you in the problem, it's a variable like x or y. So basically, all we'll have to do is plug in our 3 millimeters, which is our radius, which is the r. So we'll do circumference equals 2 pi times 3. So our answer would be 6 pi. So it'll be just like that, which equals which is selection B, 6 pi, and don't forget your measurement, which is millimeters. Okay, easy on circumference. So all you have to do is utilize your formulas. Let's move on and let's do number 5, which is another formula that we need for circles as well. So 5 says, find the area of circle I, which they give us a picture. So let's do our picture. You got a radius here, and it gives us that's 11 millimeters. Okay? So our area on our formula sheet states that area equals pi r squared, which is our radius. So all we have to do is plug in our numbers. Area equals pi times radius squared, which is 11 squared. So area equals 121 millimeters. Oops, not just millimeters. You have to put your pi too. Pi millimeters, and since it's area, it's squared. So your answer here would be C, which there is a typo. It says 12 pi millimeters squared, but it's 121. Just so you know, that's a typo in the book. So let's move on to number 10, which is another section of, it's called concentric circles, which we need to know how to do as well. Okay, this one looks confusing, but don't let it get confusing. It's easy. Just utilize your formulas. So you have a circle within a circle, and you have a shaded region, which is like this. Okay, and they give us a radius from the center of the big circle to the top. And then they give us a radius within the small circle here. So it says, in 2 concentric circles, the smaller circle has a radius of 3. So we'll put our 3. While the larger circle has a radius of 5. 5. Find the area of the shaded region. So what we're going to do is find the area of the big circle, the area of the small circle, and what we'll do is subtract it, and it'll give us the area of the shaded region. So area equals pi radius squared. So for our big circle, we have area equals pi times 5 squared, which equals 25 pi. So our area for the big circle is 25 pi. The next circle we have the small circle. So take the area, which is pi radius squared. So area equals pi 3 squared. So our answer is 3, or not 3, but 9. 9 pi. So now we have the bigger circle versus the smaller circle. So all we have to do is subtract these two things. So you have 25 pi minus 9 pi. And again, your pi is like a variable. You have the same base, so you can subtract your whole numbers. So 25 minus 9 would equal 16 pi. Remember your measurement, which is millimeters. And since we're doing area, it's squared. So your answer is 16 pi millimeters squared, which is selection D. Okay, moving right along, let's do number 12. which deals with arcs and arcs and angles and their relation. And if you know the relation, it makes the problems really easy. So it says find the measure of the arc MN if the measure of angle M is 62. So we have a circle and we have an angle. And it's saying we have MON. Okay? And it's saying that the measure of MON is 62 degrees. And the relationship between an angle and the arc is that the angle and the arc are equal. So the arc that's opposite the angle will equal the same as the angle. So basically they're asking for MN, this area here. And since we know the relationship, we know that the measure of MN, the arc, equals 62 degrees. And that's your answer. So if you look at number 12, D is 62, and that is your answer. Let's look at 15, applying the same rules that we know in the relationship with arcs and angles. Okay, so 15, we have circle S. Okay, and you have an angle. We have P and R. And it gives us the measure of this arc at 298. Okay? And now it's asking us to find the measure of the central angle, which is PSR, which is here. So we know that the arc that's opposite the angle would equal each other. So we don't know this section right here, so we can't find our angle. But the measure of the circle is 360 degrees. So knowing that, all we have to do is take 298 from 360, and we'll get this section here, this arc that's opposite our angle, which will also be equal to our angle. So let's subtract. Okay, so we have 72 degrees. So here we have 72 degrees, which we also know that our angle is 72 degrees as well. So, oops, I meant to put 6. And that's a 5. I messed it up. But yeah, it's 62, not 72. So our answer would be 62 degrees. Pretty easy. We took our 298 and subtracted from 360. That would give us the measure of the arc, and the angle opposite of the arc is equal. So we get 62, which is selection A. Okay. Now that we've gone over circles, we got one more section.